So I know I said I'm not much of a gun person, and I'm really not, but the fact is that's a big application of these projectile motion type problems. So I have a gun with a muzzle speed of 150 meters per second. I want to hit a target 800 meters away, and I need to know what angle I should aim at. It turns out there are two different angles that will work. So if you want to work this out on your own, pause the video, pick back up later. First thing I'm going to do here is set up my parametric equations. So x is v naught times the cosine of theta, which I don't know, times t, which I also don't know. And the target is 800 meters away. That's an x idea. Y is, let's see, we're in meters. So we'll use 4.9, 9.8 over 2. V naught sine theta times t. We're assuming the target's on the ground and we're firing from the ground also. Since the target's on the ground, when I hit it, my position above the ground in the y direction is 0. I'm going to take the second equation, the y equation, factor out a t. So t equals 0. Well, yeah, it's on the ground before it starts too. But this is the interesting part here. So here's an expression, not a value, but an expression for t. I can take that expression for t and substitute into my other equation, my x equation. So there's the part from the x equation. Here comes the part from the y. Equals 800. Well, now we're down to one variable. Theta is the only thing that we don't know, and theta is the thing that we want. So that's good news. If I do some stuff with constants up here, I'm going to notice sine theta times cosine theta times 2 is an identity. This is 150 times, I'm going to divide one of those 150s by 2. 2 sine theta, cosine theta is the same thing as sine 2 theta. Crunch some numbers, and we have sine of 2 theta is 0.348 with a lot of 4s after it, which means values for 2 theta, so calculator, are 20.392 degrees. We'll go with degrees here because it's an application. I'm pretty sure military specialists measure in degrees and not radians. Aim your gun at 3 pi over 4. Not sure what that would be met with. So if you do an arc sine, this is what you're going to get. And then it's important to realize that there's another angle in the second quadrant that also has this as its sine value. That's 2 theta. So the two angles I can aim at are 79 degrees and 10. That was the question, was find the two angles. So if you picture what's going on, I have my beginning, I have my target on the ground here. I can hit that target either by having a very steep angle, so this is a 79-degree angle, and it's going to go way up and drop down, or by having a very shallow angle, like a line drive. Either of those will accomplish the task.